Biodiversity and conservation. Course content. Introduction to biodiversity. Types and levels of biodiversity. Importance of biodiversity. Threats to biodiversity. Conservation strategies. Protected areas and wildlife sanctuaries. Biodiversity hotspots and endemic species. Role of indigenous and local communities. Role of international agreements and organizations. Threats to biodiversity in the 21st century. Innovative technologies. The path forward. Part 1. Introduction to biodiversity. What is biodiversity? Biodiversity, short for biological diversity, refers to the variety of life on Earth. This includes the diversity within species, between species, and of ecosystems. It is a concept that captures the richness and variability of all living organisms, plants, animals, fungi, and microorganisms, as well as the ecosystems they form and the ecological processes they participate in. Biodiversity is not uniformly distributed across the globe. Some areas, such as tropical rainforests and coral reefs, are especially rich in species and are referred to as biodiversity hotspots. Historical background. The term biodiversity was popularized in the 1980s, though the recognition of the variety of life has long been a part of natural history and ecological sciences. The 1992 United Nations Earth Summit in Rio de Janeiro marked a major milestone, leading to the Convention on Biological Diversity, CBD, an international treaty dedicated to conserving biological diversity, sustainable use of its components, and fair sharing of benefits arising from genetic resources. Components of biodiversity. Biodiversity is typically studied and categorized into three major levels. Genetic diversity, the variation of genes within species. This includes the differences in DNA among individuals of the same species, which is crucial for adaptation and survival. Species diversity, the variety of species within a habitat or region. This includes the number of species and their relative abundance. Ecosystem diversity, the diversity of ecosystems in a region. This encompasses the variety of habitats, ecological processes, and communities. Distribution of biodiversity. Biodiversity is unevenly distributed across the planet. The equatorial region tends to have higher biodiversity compared to the polar regions. Tropical forests, which cover only about 7% of the Earth's surface, harbor more than 50% of the world's species. Similarly, coral reefs are some of the most diverse marine ecosystems. Significance of studying biodiversity. Understanding biodiversity is essential for multiple reasons. Ecological balance. Biodiversity ensures the stability of ecosystems by supporting essential processes like pollination, nutrient cycling, and decomposition. Resilience. Diverse ecosystems are better equipped to handle disturbances, such as disease outbreaks or climate change. Economic value. Biodiversity supports agriculture, forestry, fisheries, and tourism. It also provides resources for medicines and raw materials. Cultural and aesthetic value. Biodiversity enriches human cultures through traditions, arts, and spiritual beliefs tied to nature. Challenges in biodiversity assessment. Despite technological advancements, assessing global biodiversity remains a challenge due to incomplete knowledge of many species, especially microorganisms, difficulty in accessing certain habitats, like deep oceans or dense forests, continuous changes in land use, climate, and pollution affecting biodiversity patterns. The way forward. Protecting biodiversity begins with understanding its value and complexity. Scientific research, public awareness, sustainable practices, and strong legal frameworks are all vital for conservation. This course explores these themes in depth, providing insights into how humanity can coexist with and protect the vast web of life that sustains us. Part 2. Types and levels of biodiversity. Biodiversity exists on multiple levels, each contributing uniquely to the complexity and functionality of life on Earth. Understanding these levels is essential for effective conservation and sustainable management of natural resources. Genetic diversity. Definition: genetic diversity refers to the variation in genetic composition within a species. This includes differences among individuals in the same population as well as between populations. Significance: provides the raw material for evolution and adaptation through natural selection. Ensures species resilience against diseases, environmental changes, and climate stress. Plays a critical role in agricultural systems by offering a pool of traits for crop improvement and livestock breeding. Examples: different breeds of dogs or varieties of rice. Resistance to pests in some crop strains. Adaptability of wild species to changing habitats. Species diversity. Definition: species diversity is the variety of species within a particular region or ecosystem. It includes species richness, the number of different species present. Species evenness, the relative abundance of each species. Significance: higher species diversity generally leads to more stable and productive ecosystems. Diverse communities can better withstand environmental stressors. It contributes to ecosystem services such as pollination, water purification, and nutrient cycling. Examples: the Amazon rainforest, home to thousands of plant and animal species. Coral reefs that support a broad range of marine life. Ecosystem diversity. Definition: ecosystem diversity refers to the variety of habitats, ecological processes, and communities in a given area. This includes natural systems like forests, wetlands, deserts, and oceans, as well as man-made ecosystems like agricultural fields. Significance: supports a wide array of species, each adapted to particular conditions. Contributes to global biogeochemical cycles and climate regulation. Provides vital ecosystem services that sustain human life and economies. Examples: grasslands that support grazing animals and maintain soil health. Wetlands that act as natural water filters and buffers against floods. Urban green spaces that support biodiversity in cities. Functional diversity. Definition: functional diversity focuses on the role species play in ecosystems rather than their taxonomic classification. It includes traits related to feeding, reproduction, and ecological roles. Significance: determines how ecosystems function and respond to changes. Enhances ecosystem resilience by supporting multiple species that perform similar ecological roles. Functional redundancy. Examples: decomposers like fungi and bacteria that recycle nutrients. Pollinators like bees, butterflies, and bats that support plant reproduction. Temporal and spatial scales of biodiversity. Biodiversity can vary across temporal scales, seasonal changes in species composition, population sizes, and ecosystem processes. Spatial scales, local, regional, and global biodiversity patterns. Understanding these patterns helps identify areas of high conservation value and the impacts of human activity over time. Measuring biodiversity. Scientists use various metrics to assess biodiversity, such as species richness and abundance. Shannon-Weiner and Simpson indices to quantify species diversity. Phylogenetic diversity, which considers evolutionary relationships among species. These tools aid in monitoring ecosystem health and guiding conservation efforts. Conclusion: Biodiversity operates at multiple interconnected levels, from genes to species to ecosystems. Protecting one level supports the others, reinforcing the need for a comprehensive conservation approach. In the next part, we will explore the importance of biodiversity to the planet and to human well-being. Part 3: Importance of biodiversity. Biodiversity is more than a measure of ecological richness. It is the foundation of life on Earth. It provides critical services, sustains livelihoods, supports economies, and enriches cultures. Understanding its importance is key to realizing why its conservation must be a global priority. Ecological importance. Ecosystem stability and resilience. Biodiverse ecosystems are more stable and resilient to environmental stressors such as droughts, diseases, and climate change. Multiple species with overlapping roles ensure that ecosystem functions continue even if some species are lost. 2. Nutrient cycling and soil formation. Decomposers like fungi and bacteria help recycle nutrients. Plants and microorganisms contribute to soil formation and fertility, supporting agriculture and natural vegetation. 3. Pollination and seed dispersal. Insects, birds, and mammals pollinate crops and wild plants. Animals such as birds and primates disperse seeds, helping forests regenerate. 4. Water and air purification. Wetlands filter pollutants from water. Forests absorb carbon dioxide and release oxygen while trapping airborne particles, improving air quality. Economic importance. Agriculture and food security. Biodiversity underpins global food systems. Genetic diversity in crops and livestock is crucial for breeding disease-resistant and climate-resilient varieties. 2. Medicine and pharmaceuticals. Many modern medicines are derived from plants, animals, and microorganisms. For example, the cancer drug paclitaxel comes from the Pacific yew tree, and quinine used to treat malaria comes from the bark of the cinchona tree. 3. Livelihoods and industries. Forestry, fisheries, agriculture, and ecotourism rely heavily on biodiversity. Millions of people, especially in rural and indigenous communities, depend directly on natural ecosystems for their sustenance and income. 4. Biotechnology and innovation. Genetic resources from diverse organisms are vital for research, technological innovation, and biotechnology applications, including biofuels and sustainable materials. Cultural and aesthetic importance. Spiritual and religious significance. Many cultures view nature as sacred. Sacred groves, rivers, and animals are revered in religions and traditions around the world. 2. Cultural identity and indigenous knowledge. Biodiversity shapes the cultural identity of communities. Indigenous peoples have deep knowledge of local biodiversity, which is key for sustainable resource management. 3. Recreation and inspiration. Natural landscapes and wildlife offer inspiration for art, literature, and music. Activities like birdwatching, hiking, and photography promote mental well-being and connect people with nature. Scientific and educational value. Biodiversity offers immense opportunities for scientific research. Studying species interactions, genetic traits, and ecosystem dynamics helps us understand the natural world and apply that knowledge to solving global challenges, from food security to climate change. Biodiversity and ecosystem services. Biodiversity supports 4 key types of ecosystem services. Provisioning services: food, water, timber, and medicine. Regulating services: climate regulation, disease control, water purification. Cultural services: recreation, spiritual enrichment, and aesthetic experiences. Supporting services: nutrient cycling, soil formation, and primary production. The degradation of biodiversity threatens these services, potentially leading to ecosystem collapse and economic losses. Biodiversity and sustainable development. Biodiversity is a cornerstone of sustainable development. The UN's Sustainable Development Goals, SDGs, recognize its importance in goals related to poverty reduction, health, climate action, and life on land and in water. Conserving biodiversity ensures future generations inherit a livable planet. Conclusion: biodiversity is vital for ecological balance, economic prosperity, cultural richness, and scientific advancement. Its loss would not only affect nature, but also threaten human survival. In the following part, we will examine the threats to biodiversity and the urgent need to mitigate them. Part 4: Threats to biodiversity. Despite its immense value, biodiversity across the globe is facing an unprecedented crisis. Human activities have accelerated the rate of species extinction, disrupted ecosystems, and degraded natural habitats. Understanding the various threats to biodiversity is the first step toward devising effective conservation strategies. Habitat loss and fragmentation. Deforestation, large-scale clearing of forests for agriculture, urbanization, mining, and infrastructure destroys habitats and displaces countless species. Tropical rainforests, among the most biodiverse regions on Earth, are particularly vulnerable. 2. Urban expansion. Rapid and unplanned urbanization converts natural habitats into built environments, causing fragmentation that isolates wildlife populations and limits their movement and genetic exchange. 3. Agriculture and land use change. Monoculture farming, pasture expansion, and land conversion reduce habitat complexity and biodiversity. Intensive agriculture often results in soil degradation, water pollution, and loss of native species. Overexploitation of natural resources. Overfishing, unsustainable fishing practices have led to the depletion of fish stocks and the collapse of marine ecosystems. 2. Hunting and poaching. Many species are endangered due to illegal hunting and poaching for meat, medicine, pets, or trophies. Examples include elephants' ivory, tigers' skins, and rhinos' horns. 3. Overharvesting of plants. Medicinal and ornamental plants are often collected at unsustainable rates, threatening their survival in the wild. Pollution. Water pollution, industrial waste, agricultural runoff, pesticides and fertilizers, and plastic debris contaminate rivers, lakes, and oceans, endangering aquatic life. 2. Air pollution. Airborne pollutants such as sulfur dioxide, nitrogen oxides, and particulate matter can damage vegetation, acidify soils and water bodies, and affect animal health. 3. Soil pollution. Heavy metals, pesticides, and industrial chemicals degrade soil health, reducing its fertility and biological activity. 4. Noise and light pollution. These less visible pollutants disturb natural behaviors in wildlife, including migration, reproduction, and feeding. Invasive alien species. Non-native species introduced intentionally or accidentally can outcompete, prey on, or bring diseases to native species, leading to biodiversity loss. Examples include the water hyacinth in freshwater ecosystems, the brown tree snake in Guam, zebra mussels in North American waterways. Climate change. Global warming and climate variability affect biodiversity by altering temperature and rainfall patterns, causing shifts in species distribution, disrupting breeding cycles, and leading to habitat loss. Examples: coral bleaching due to ocean warming, polar bears losing habitat due to melting ice, altered migration patterns of birds and marine species. Disease and pathogens. Emerging infectious diseases, often facilitated by human disturbance and global trade, can devastate wildlife populations. For instance, chytrid fungus has severely impacted amphibians worldwide. White nose syndrome is decimating bat populations in North America. Human-wildlife conflict. Encroachment into natural habitats increases encounters between humans and wildlife, often leading to conflict. This can result in injury, livestock loss, or retaliatory killings of animals, further endangering their survival. Socioeconomic and institutional factors. Lack of environmental awareness and education. Weak law enforcement and governance in managing protected areas. Short-term economic incentives driving unsustainable exploitation. Conflicts and war, which often disrupt conservation efforts and damage ecosystems. Conclusion. Biodiversity is under siege from a range of interconnected threats, most of which are driven by human activity. The scale and urgency of these threats demand immediate and coordinated action. In the next part, we will explore conservation strategies that can help protect and restore biodiversity for the benefit of present and future generations. Part 5: Conservation Strategies. Conserving biodiversity is essential for sustaining the ecological balance of the planet and securing resources for future generations. Given the variety and complexity of threats facing biodiversity, a wide range of strategies, both in situ on-site and ex situ off-site, are necessary to ensure effective conservation. In situ conservation. In situ conservation refers to the protection of species in their natural habitats. It helps maintain natural interactions and evolutionary processes, making it the most effective long-term conservation strategy. 1. Protected areas. National parks, wildlife sanctuaries, and biosphere reserves protect entire ecosystems and species within them. Community reserves involve local communities in managing biodiversity sustainably. 2. Habitat restoration. Reforestation, wetland restoration, and soil reclamation help recover degraded habitats. Restoration ecology aims to return ecosystems to their original state, or as close as possible. 3. Conservation corridors. Wildlife corridors connect fragmented habitats, allowing species to migrate, disperse, and maintain genetic diversity. 4. Sacred groves and indigenous practices. Many indigenous and local communities maintain sacred landscapes that function as informal conservation areas. Traditional knowledge and cultural values play a key role in preserving biodiversity. Ex situ conservation. Ex situ conservation involves preserving components of biodiversity outside their natural habitats. 1. Botanical gardens and zoos. Serve as educational, research, and breeding centers. Maintain gene pools of rare and endangered species. 2. Seed banks and gene banks. Store seeds, pollen, and DNA of plant and animal species for future use. Ensure genetic diversity is preserved for agricultural and conservation purposes. 3. Captive breeding and reintroduction. Breeding endangered species in controlled environments and reintroducing them into the wild. Success stories include the Arabian oryx, California condor, and Indian gharial. 4. Cryopreservation. Freezing and storing genetic materials like sperm, eggs, and tissues for long-term conservation. Ecosystem-based approaches. 1. Ecosystem-based management. Managing ecosystems holistically, rather than focusing on individual species. Balances conservation goals with human needs through sustainable practices. 2. Landscape and watershed approaches. Integrated planning and management of landscapes and watersheds ensure biodiversity is protected across multiple land uses. Legal and institutional frameworks. 1. International agreements. Convention on Biological Diversity, CBD, promotes sustainable development and equitable benefit sharing. CITES, Convention on International Trade in Endangered Species, regulates trade in endangered species. Ramsar Convention protects wetlands of international importance. 2. National legislation. Many countries have enacted wildlife protection laws, biodiversity acts, and forest conservation regulations. Environmental impact assessments, EIAs, ensure developmental projects consider biodiversity impacts. Community-based conservation. Engaging local communities in conservation efforts ensures sustainability and equitable benefit sharing. Joint forest management, JFM, and participatory rural appraisal, PRA, involve communities in decision-making and resource management. Ecotourism provides alternative livelihoods while promoting conservation awareness. Role of science and technology. 1. Geographic Information Systems, GIS, and remote sensing. Monitor land use changes, habitat loss, and biodiversity trends. 2. Genetic and molecular tools. DNA barcoding, population genetics, and genomics aid in species identification and conservation planning. 3. Artificial intelligence and big data. Help predict species distribution, track migration patterns, and detect illegal activities such as poaching. Education and awareness. Public education is vital for fostering a culture of conservation. Schools, media, and NGOs play an important role in promoting sustainable behavior, spreading awareness about endangered species, building support for conservation initiatives, sustainable use and incentives, promoting sustainable forestry, fishing, and agriculture to reduce pressure on ecosystems. Economic incentives, such as payment for ecosystem services, PES, reward communities for conserving biodiversity. Conclusion. Conservation of biodiversity requires a multifaceted approach that includes habitat protection, species preservation, sustainable development, and community engagement. By integrating traditional knowledge with scientific innovation and policy frameworks, we can ensure a more balanced and biodiverse future. In the next part, we will delve deeper into protected areas and wildlife sanctuaries, the frontline of in situ conservation efforts. Part 6: Protected Areas and Wildlife Sanctuaries. Protected areas are the cornerstone of global biodiversity conservation. They provide safe habitats for flora and fauna, preserve critical ecosystems, and serve as living laboratories for research and education. In this part, we explore the types, roles, management, and challenges of protected areas, with a focus on wildlife sanctuaries and other conservation landscapes. What are protected areas? A protected area is a clearly defined geographical space that is recognized, dedicated, and managed to achieve the long-term conservation of nature. These areas can vary in size, function, and level of protection. The International Union for Conservation of Nature, IUCN, classifies protected areas into 6 categories, ranging from strict nature reserves, Category EA, to protected areas with sustainable use of natural resources, Category V. Types of protected areas. 1. National parks. Large areas set aside to protect large-scale ecological processes and species. No human habitation or exploitation is allowed, except for tourism and research. Example: Yellowstone National Park, USA, Kaziranga National Park, India. 2. Wildlife sanctuaries. Areas where wildlife and their habitats are protected, but certain human activities like grazing or resource collection may be permitted under regulation. Example: Bharatpur Bird Sanctuary, India, Samburu National Reserve, Kenya. 3. Biosphere reserves. Recognized by UNESCO's Man and the Biosphere (MAB) program. Comprise 3 zones: core, strict protection; buffer, limited activity; and transition, sustainable use. Example: Nilgiri Biosphere Reserve, India, Kruger to Canyons Biosphere Reserve, South Africa. 4. Conservation reserves and community reserves. Areas protected with the participation of local communities. designed to protect biodiversity while allowing for traditional practices and sustainable use. 5. Marine Protected Areas, MPAs. Designated to conserve marine biodiversity, ecosystems, and cultural resources. Example: Great Barrier Reef Marine Park, Australia. Importance of protected areas. Habitat conservation. Preserve ecosystems and serve as refuges for endangered and endemic species. Biodiversity hotspots. Many protected areas fall within global biodiversity hotspots. Climate regulation. Forested areas act as carbon sinks and help mitigate climate change. Water security. Protect watersheds and ensure clean water supply. Cultural and spiritual value. Many protected areas hold cultural significance and support indigenous practices. Research and education. Offer opportunities for ecological research and environmental education. Key features of wildlife sanctuaries. Focused on protecting specific species or groups of wildlife. Human activities like photography, ecotourism, and limited harvesting may be allowed. Often established in areas with rich biodiversity and unique species. May be seasonal or migratory habitats, e.g., bird sanctuaries. Management of protected areas. 1. Legal framework. Protected areas are governed by national laws and international agreements. Environmental laws define zoning, allowed activities, and penalties for violations. 2. Scientific monitoring. Regular surveys, camera trapping, satellite imagery, and population monitoring help assess the health of ecosystems and species. 3. Community involvement. Co-management with local and indigenous communities enhances effectiveness and reduces conflicts. Benefit sharing mechanisms encourage local stewardship. 4. Infrastructure and staffing. Effective protection requires trained staff, visitor facilities, surveillance equipment, and transport access. Challenges facing protected areas. 1. Encroachment and land use change. Illegal settlements, farming, and logging threaten the integrity of protected areas. 2. Poaching and illegal wildlife trade. High-value species attract poachers. Anti-poaching efforts need to be strengthened. 3. Tourism pressure. Unregulated tourism can lead to habitat degradation and pollution. 4. Climate change. Alters species distribution, water availability, and fire regimes, impacting protected ecosystems. 5. Funding and resource constraints. Many protected areas lack adequate funding and staffing for effective management. 6. Human-wildlife conflict. Wildlife entering human settlements can cause damage, leading to retaliatory killings. Strategies to enhance effectiveness. Integrated management plans, tailored to the ecological and social context of each area. Transboundary conservation areas. Collaboration across national borders to conserve shared ecosystems. Technology use, drones, GPS tracking, and eye-based surveillance for monitoring and anti-poaching. Ecotourism models. Sustainable tourism can generate revenue and awareness without harming biodiversity. Capacity building, training local communities and forest officials in conservation best practices. Conclusion. Protected areas, especially wildlife sanctuaries, play a critical role in preserving biodiversity and maintaining ecosystem services. However, their success depends on effective management, strong legal frameworks, community support, and global cooperation. In the next part, we will explore biodiversity hotspots and endemic species, areas of exceptional richness and conservation priority. Part 7. Biodiversity hotspots and endemic species. Certain regions of the Earth are exceptionally rich in biodiversity and are home to unique species found nowhere else. These regions, known as biodiversity hotspots, are crucial for global conservation efforts. This part explores what makes a region a hotspot, the concept of endemic species, and why these areas demand urgent protection. 7.1 What is a biodiversity hotspot? A biodiversity hotspot is a biogeographic region that meets two key criteria. It must have at least 1,500 species of vascular plants as endemics, species found only in that region. It must have lost at least 70% of its original natural vegetation, indicating significant threat. This concept was developed by Norman Myers in 1988 and later expanded by Conservation International. 7.2 Global biodiversity hotspots. There are currently 36 recognized biodiversity hotspots across the globe, which cover just over 2.3% of the Earth's land surface but contain more than 50% of the world's endemic plant species. Some major global hotspots include Amazon rainforest, South America; Congo Basin, Africa; Himalayas, Asia; Indo-Burma, Southeast Asia; Sundaland, Malaysia and Western Indonesia; Mediterranean Basin, Europe, North Africa, Middle East; Madagascar, and the Indian Ocean Islands. Biodiversity hotspots in India. India is home to 4 major biodiversity hotspots. Himalayas includes the entire Indian Himalayan region and parts of Nepal, Bhutan, and Myanmar. Indo-Burma covers northeastern India and Southeast Asia. Western Ghats and Sri Lanka includes southwestern India and parts of Sri Lanka. Sundaland includes the Nicobar Islands and parts of Indonesia and Malaysia. These areas harbor thousands of endemic species, from amphibians and reptiles to flowering plants and butterflies. Endemic species. An endemic species is a plant, animal, or microorganism that is native to a particular geographic region and found nowhere else in the world. Types of endemism. Paleoendemics, species that were once widespread but now survive in a limited area. Neoendemics, recently evolved species found only in a specific region. Examples: the lion-tailed macaque, Western Ghats, India; the lemurs of Madagascar; the Galapagos tortoise, Ecuador; the Wollemi pine, Australia. Importance of hotspots and endemic species. Genetic diversity. Hotspots are reservoirs of unique genetic material crucial for crop improvement, medicine, and climate resilience. Ecosystem services. These regions provide water purification, pollination, carbon storage, and soil fertility. Evolutionary value. Endemic species often represent ancient evolutionary lineages, offering insights into Earth's biological history. Cultural and economic significance. Indigenous communities often rely on biodiversity hotspots for livelihoods, food, and traditions. Threats to hotspots and endemic species. Hotspots are especially vulnerable due to deforestation and habitat fragmentation, climate change, invasive species, overexploitation, urbanization, and infrastructure development. Because endemic species are restricted to specific regions, they are at higher risk of extinction if their habitat is disturbed. Conservation strategies in hotspots. Strict protection measures in core areas. Sustainable development in buffer zones. Community-based management to ensure local stewardship. Research and monitoring of endemic species and ecosystem health. Restoration ecology to rehabilitate degraded habitats. Funding and international support through programs like the Global Environment Facility, GEF, and UNESCO. Conclusion. Biodiversity hotspots and endemic species represent the most irreplaceable and threatened parts of our natural heritage. Protecting these regions is essential not only for conserving Earth's unique life forms, but also for maintaining global ecological stability. In the next part, we will examine the role of indigenous and local communities in conservation, highlighting the symbiotic relationship between people and nature. Part 8. The role of indigenous and local communities in conservation. Conservation is not only a scientific or legal endeavor, it is deeply social and cultural. Indigenous peoples and local communities, IPLCs, have lived in close harmony with nature for centuries, and their traditional knowledge, practices, and belief systems have played a critical role in preserving biodiversity. Recognizing and empowering these communities is essential for the success of modern conservation efforts. Indigenous knowledge and biodiversity. Traditional ecological knowledge, TEK, refers to the knowledge systems developed by indigenous communities through generations of interaction with their natural surroundings. This includes sustainable harvesting techniques, seasonal resource management, understanding of species behavior and ecosystems, spiritual and cultural practices that promote conservation. Example: in the Amazon, indigenous tribes rotate their agricultural plots to allow forests to regenerate. In India, sacred groves are protected patches of forest maintained for spiritual reasons, often harboring rare species. Community-led conservation models. 1. Community conserved areas, CCAs. These are natural habitats conserved by local communities through customary laws or collective decision-making. Example: the Bishnoi community in Rajasthan, India, protects blackbucks and trees out of religious duty. 2. Joint forest management, JFM. Implemented in several countries, including India, JFM involves collaboration between forest departments and local communities for forest protection and benefit sharing. 3. Indigenous protected and conserved areas, IPCAs. Recognized globally, these areas are governed and managed by indigenous communities according to their laws and values. Benefits of involving local communities. Sustainability. Local stewardship often leads to more sustainable and culturally acceptable conservation practices. Cost-effectiveness. Community management reduces costs for enforcement and monitoring. Social equity. Ensures that conservation does not come at the expense of local livelihoods or cultural rights. Conflict resolution. Reduces conflicts between conservation authorities and local populations by promoting dialogue and cooperation. Legal and policy support. International instruments. United Nations Declaration on the Rights of Indigenous Peoples, UNDRIP, affirms the rights of indigenous peoples to manage their lands and resources. Convention on Biological Diversity, CBD, Article 8J, emphasizes respecting traditional knowledge and involving communities in conservation. National policies. Many countries now include provisions for community reserves, tribal forest rights, and local governance of natural resources. Challenges faced by indigenous and local communities. Land insecurity, lack of legal recognition of traditional territories. Marginalization, exclusion from decision-making processes and benefits. Cultural erosion, modernization and external influences can erode traditional practices. Development pressures, infrastructure projects, mining, and tourism often threaten community lands. Case studies. The Maasai in East Africa. Pastoralist communities like the Maasai have managed savanna ecosystems for generations. Their migratory grazing practices help maintain grassland biodiversity. 2. The Khasi Hills, India. Tribal councils, Dorbar Shnongs, in Meghalaya, manage community forests that are rich in endemic species. 3. The Kayapa people, Brazil. Using GPS mapping and partnerships with NGOs, the Kayapa defend millions of hectares of Amazon rainforest from deforestation and mining. Enhancing community participation. To strengthen the role of local communities in conservation, governments and organizations can Provide legal recognition of community land and resource rights. Support education and capacity building in conservation practices. Ensure equitable benefit sharing from ecotourism and resource use. Incorporate traditional knowledge into scientific conservation plans. Create inclusive governance platforms for joint decision-making. Conclusion. Indigenous and local communities are not just stakeholders in conservation, they are often its pioneers and protectors. Their deep connection to the land, coupled with time-tested ecological wisdom, makes them invaluable allies in the fight to conserve biodiversity. Empowering these communities is not only an ethical imperative, but a practical necessity for sustaining the planet's rich biological heritage. In the next part, we will explore the role of international agreements and organizations in biodiversity conservation, highlighting global efforts and collaborations. Part 9. The role of international agreements and organizations in biodiversity conservation. Biodiversity loss is a global issue that transcends national borders. Ecosystems and species often span multiple countries, and threats such as climate change, habitat destruction, and illegal wildlife trade are international in scope. Hence, international cooperation is essential for effective biodiversity conservation. This part explores the key agreements, conventions, and organizations that drive global biodiversity efforts. Importance of international cooperation. Shared ecosystems. Rivers, mountain ranges, forests, and migratory routes often cross borders. Global threats. Climate change, invasive species, and pollution require coordinated responses. Equity and funding. Developing countries often harbor rich biodiversity but lack the financial means to protect it. International support helps bridge this gap. Standardization. Global agreements set common goals, frameworks, and best practices for biodiversity protection. Key international agreements. 1. Convention on Biological Diversity, CBD, 1992. Objectives: conservation of biodiversity, sustainable use of its components, and fair and equitable sharing of benefits from genetic resources. Led to the creation of national biodiversity strategies and action plans, NBSAPs. Introduced the Aichi Biodiversity Targets, 2010 to 2020, and Kunming-Montreal Global Biodiversity Framework, 2022, with 23 new targets to be achieved by 2030. 2. CITES, Convention on International Trade in Endangered Species of Wild Fauna and Flora, 1975. Regulates international trade in endangered species through a permit system. Helps control overexploitation and poaching. Covers more than 38,000 species of animals and plants. 3. Ramsar Convention, 1971. Focuses on the conservation and wise use of wetlands. Recognizes wetlands of international importance, known as Ramsar sites. Promotes integrated water and land management. 4. United Nations Framework Convention on Climate Change, UNFCCC, 1992. Although primarily focused on climate change, it plays a critical role in biodiversity conservation through mechanisms like REDD+, reducing emissions from deforestation and forest degradation. Climate change adaptation and mitigation efforts often overlap with conservation goals. 5. Convention on Migratory Species, CMS, 1979. Aims to conserve migratory species and their habitats across international boundaries. Promotes cooperation among range states. Supporting global institutions and organizations. 1. International Union for Conservation of Nature, IUCN. Maintains the Red List of threatened species, assessing extinction risk. Develops guidelines for protected area management and biodiversity conservation. Leads global initiatives like the World Conservation Congress. 2. United Nations Environment Programme, UNEP. coordinates environmental activities, and promotes sustainable development. Hosts the World Environment Day and publishes vital reports on global biodiversity. 3. Worldwide Fund for Nature, WWF. Works on conservation through field projects, education, advocacy, and corporate partnerships. Runs global campaigns to protect flagship species like tigers, pandas, and whales. 4. Convention on Biological Diversity's Global Environment Facility, GEF. Provides financial support to developing countries for implementing biodiversity projects. Funds conservation of protected areas, sustainable land use, and climate adaptation. 5. Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES. Provides scientific assessments on biodiversity to guide policy decisions. Often called the IPCC for biodiversity. Regional and bilateral initiatives. European Union Biodiversity Strategy sets goals for nature restoration and protection across EU nations. ASEAN Heritage Parks, a regional network of protected areas in Southeast Asia. Transboundary protected areas, jointly managed parks like the Great Limpopo Transfrontier Park, South Africa, Mozambique, Zimbabwe. Achievements and limitations. Achievements. Protection of millions of hectares of ecosystems. Recovery of certain species, e.g. snow leopard, black rhino, through targeted action. Better public awareness and scientific research. Limitations. Many countries lag in implementing biodiversity targets. Insufficient funding and political will. Fragmented data and weak enforcement mechanisms. The way forward. Stronger integration of biodiversity into development and economic planning. Inclusive governance involving indigenous peoples and local communities. Nature-positive economies that promote green jobs and sustainable resource use. Accountability mechanisms to track and ensure progress toward global targets. Conclusion. International agreements and organizations play a pivotal role in biodiversity conservation by setting common goals, offering technical and financial support, and encouraging cooperation among nations. While significant progress has been made, ongoing commitment and innovation are needed to address the biodiversity crisis at the global scale. The next part will focus on threats to biodiversity in the 21st century, offering a closer look at the challenges we must overcome. Part 10. Threats to biodiversity in the 21st century. Despite global efforts to conserve biodiversity, the natural world continues to face unprecedented pressures. Human activities are altering ecosystems at an accelerating rate, pushing countless species toward extinction. In this part, we examine the key threats facing biodiversity in the 21st century, their drivers, and the cascading effects they cause across ecosystems. Overview of biodiversity loss. According to recent estimates, the current extinction rate is 100 to 1,000 times higher than the natural background rate. Over 1 million species are at risk of extinction in the coming decades, IPBES 2019. The Living Planet Index shows a nearly 70% decline in wildlife populations since 1970. These alarming trends highlight the scale of the biodiversity crisis we face today. Major threats to biodiversity. 1. Habitat loss and fragmentation. The conversion of forests, wetlands, and grasslands into agricultural land, urban areas, and infrastructure is the leading cause of biodiversity loss. Fragmentation creates small, isolated populations that are more vulnerable to extinction. Example: deforestation in the Amazon and Southeast Asia for soy, palm oil, and cattle grazing. 2. Overexploitation of resources. Overfishing, poaching, unsustainable logging, and excessive harvesting of plants and animals reduce population sizes and genetic diversity. Example: the collapse of cod fisheries in the North Atlantic, illegal rhino horn trade in Africa. 3. Climate change. Rising temperatures, shifting rainfall patterns, and extreme weather events disrupt ecosystems and species life cycles. Polar, alpine, and coral reef ecosystems are especially vulnerable. Coral bleaching, shifts in migratory patterns, and mismatched seasonal cues are common impacts. 4. Invasive alien species. Non-native species introduced by human activity can outcompete, prey on, or bring diseases to native species. Example: the introduction of brown tree snakes to Guam led to the extinction of several native bird species. 5. Pollution. Pesticides, plastics, oil spills, heavy metals, and air and water pollution degrade ecosystems. Eutrophication from nutrient runoff leads to algal blooms and dead zones in water bodies. Microplastics affect marine and freshwater organisms at all trophic levels. 6. Disease and pathogens. Diseases like chytridiomycosis in amphibians and avian flu in birds have wiped out entire populations. Global trade and travel accelerate the spread of pathogens. Indirect drivers of biodiversity loss. Population growth increases demand for land, water, food, and energy. Unsustainable consumption. Overuse of resources driven by consumer culture and economic growth models. Policy and governance gaps. Weak enforcement, poor land use planning, and lack of community involvement. Global trade and market forces. Demand for wildlife products, timber, and exotic pets fuels illegal trade. Synergistic effects and tipping points. Many threats interact and reinforce each other. For example, climate change exacerbates habitat degradation. Pollution weakens organisms, making them more susceptible to disease. Invasive species thrive in disturbed ecosystems. Tipping points may occur when ecosystems degrade to a state from which they cannot recover, leading to irreversible biodiversity loss, e.g., Amazon turning into a savanna due to deforestation and climate stress. Impacts of biodiversity loss. Loss of ecosystem services, reduced pollination, water purification, soil fertility, and climate regulation. Food and water insecurity. Collapse of fisheries and freshwater systems affects human livelihoods. Economic consequences. Billions lost annually from reduced tourism, resource availability, and disaster resilience. Health risks. Biodiversity loss increases the likelihood of zoonotic disease transmission, e.g., COVID-19. Cultural erosion. Indigenous knowledge and cultural identity tied to biodiversity are at risk. Addressing the threats. Integrated land use planning. Balance conservation with development. Stronger legal frameworks. Enforce laws against illegal trade and habitat destruction. Climate adaptation and mitigation. Align conservation strategies with climate goals. Public awareness and education. Change consumption patterns and promote responsible behavior. International cooperation. Tackle transboundary threats through global agreements. Conclusion. Biodiversity faces its greatest challenge in human history. The threats are complex, interconnected, and escalating. However, they are not insurmountable. By understanding the causes and consequences of biodiversity loss, we can design better conservation strategies, foster cooperation, and build a future where humans and nature coexist harmoniously. In the next part, we will delve into innovative technologies and approaches for biodiversity conservation, exploring how science and innovation can help reverse the tide. Part 11. Innovative technologies and approaches for biodiversity conservation. In the face of accelerating biodiversity loss, science and technology have emerged as powerful tools to support and enhance conservation efforts. From satellite imaging to genetic analysis, innovative approaches are enabling researchers, conservationists and communities to monitor ecosystems, detect threats, and implement solutions more effectively than ever before. The role of technology in conservation. Conservation is no longer limited to boots-on-the-ground fieldwork. Modern technologies provide real-time monitoring of wildlife and habitats, predictive modeling for habitat loss and species decline, improved enforcement through surveillance tools, enhanced data collection and sharing. These technologies support evidence-based decision-making and increase the efficiency of conservation efforts globally. Geographic Information Systems (GIS) and remote sensing. GIS allows mapping of ecosystems, species distribution, land use changes, and conservation areas. Remote sensing via satellites and drones enables observation of large or inaccessible areas. Applications: detecting deforestation, tracking illegal logging or mining, monitoring coral reef health. Example: NASA and Google Earth Engine have partnered with conservation organizations to monitor changes in forest cover. Camera traps and acoustic monitoring. Camera traps capture images of wildlife without human presence, useful for studying elusive or nocturnal animals. Bioacoustic monitoring uses sound recorders to detect species, especially birds, frogs, and whales. These methods provide valuable data on species abundance, behavior, and migration patterns. Environmental DNA, EDNA. Organisms leave traces of genetic material, e.g., skin cells, hair, waste, in the environment. EDNA sampling allows detection of species in water or soil without direct observation. Benefits: cost-effective, non-invasive, useful for detecting rare or invasive species. Artificial intelligence, AI and machine learning. AI can analyze vast amounts of data from camera traps, satellite images, or bioacoustic devices. Helps identify species, detect poaching patterns, and predict ecosystem changes. Example: AI algorithms trained to recognize individual animals like elephants or whales for population studies. Drones and UAVs, unmanned aerial vehicles, provide aerial views for habitat mapping, anti-poaching patrols, and wildfire detection. Can be equipped with thermal sensors to detect animals or illegal activity at night. Conservation drones and robotics. Used for planting trees, delivering biological samples, or monitoring coastal erosion. Robotics in marine conservation help clean up plastic pollution and survey coral reefs. Blockchain for conservation finance and transparency. Blockchain technology is being used to ensure transparency in conservation funding. Tracks the flow of carbon credits, biodiversity offsets, and eco-certification. Citizen science and mobile technology. Apps and platforms like iNaturalist, eBird, and Map of Life allow the public to contribute biodiversity data. Enhances data collection while raising awareness and engagement. Genetic technologies and synthetic biology. Conservation genetics helps maintain healthy populations by understanding genetic diversity. Gene banking stores DNA of endangered species. CRISPR and gene editing are being explored to prevent disease in wildlife or restore extinct species, though these remain ethically debated. Challenges and considerations. Access and affordability. Advanced technologies can be expensive for local or developing country initiatives. Data privacy and ethics. Use of drones and tracking devices must respect community rights and animal welfare. Technical expertise. Effective use of tech requires capacity building and collaboration. Over-reliance risk. Technology should complement, not replace, community engagement and ecological knowledge. Future prospects. Integration of technologies into conservation planning is expected to grow rapidly. Predictive modeling, digital twins of ecosystems, and AI-powered early warning systems could revolutionize conservation. Emphasis will remain on combining innovation with inclusivity and ethics. Conclusion: technological innovation is reshaping the way we understand, monitor, and protect biodiversity. While not a panacea, these tools can greatly enhance conservation outcomes when paired with traditional knowledge, inclusive governance, and sound ecological principles. In the final part, we'll explore the path forward for global biodiversity conservation, emphasizing holistic strategies for a sustainable future. Part 12: the path forward for global biodiversity conservation. As we confront the twin crises of biodiversity loss and climate change, the imperative to conserve and restore the natural world has never been more urgent. This final part explores integrated, forward-looking strategies to halt biodiversity decline and foster a harmonious relationship between people and nature. The need for a paradigm shift. Conservation must evolve from isolated projects to a holistic, systemic approach. It requires a fundamental rethinking of how societies interact with ecosystems, transitioning from exploitation to regeneration and stewardship. This transformation involves prioritizing ecological integrity, integrating biodiversity into all sectors of development, empowering local communities, and respecting indigenous knowledge, aligning conservation with human well-being, mainstreaming biodiversity across sectors. Biodiversity considerations should be embedded in agriculture. Promote agroecology, crop diversity, and pollinator-friendly farming. Forestry. Practice sustainable logging, reforestation, and community forest management. Fisheries. Enforce sustainable quotas, marine protected areas, and ecosystem-based management. Infrastructure and urban planning. Design green cities with biodiversity corridors and urban green spaces. Finance and business. Develop nature-positive investments and biodiversity disclosure frameworks. Nature-based solutions, NBS. Nature-based solutions are actions that work with and enhance ecosystems to address societal challenges, providing benefits for biodiversity and human well-being. Examples: restoring mangroves to protect coasts and support marine life. Urban green roofs to reduce heat and support pollinators. Rewilding landscapes to restore natural processes. NBS promote resilience, cost-effectiveness, and sustainability. Indigenous and community-led conservation. Indigenous peoples and local communities, IPLCs, manage over 1/3 of the world's intact forests and play a vital role in conservation. Key principles: recognize land and resource rights. Support traditional ecological knowledge. Co-create conservation plans with local participation. Ensure equitable benefit sharing. Respecting cultural values and governance systems strengthens both biodiversity outcomes and social justice. Policy and governance innovations. Strong governance is essential for biodiversity conservation. Necessary measures include enforcing environmental laws and penalties, creating and managing protected areas effectively, incentivizing private sector conservation, international cooperation through treaties and transboundary efforts, environmental impact assessments, biodiversity offsetting, and ecosystem service valuation can inform better decision-making. Education, awareness, and cultural change. Conservation success depends on public awareness and values. Strategies. Environmental education in schools and universities. Citizen science and community engagement. Media campaigns and storytelling to shift attitudes. Promoting ecological literacy and sustainability ethics. Changing societal values is as important as changing policies. Financing biodiversity conservation. Sustainable conservation requires long-term funding. Sources: government and donor funding, green bonds and biodiversity credits, payment for ecosystem services (PES), public-private partnerships. Innovative financial mechanisms, like debt-for-nature swaps, can help countries invest in conservation while managing national debt. Global biodiversity frameworks and targets. The Kunming-Montreal Global Biodiversity Framework, 2022, outlines a global roadmap to halt and reverse biodiversity loss by 2030. Its goals include protecting 30% of land and ocean, 30 by 30 goal, restoring degraded ecosystems, reducing species extinction rates, ensuring sustainable use of biodiversity. These targets demand accountability, monitoring, and equitable implementation. Challenges and opportunities. Challenges: political resistance and short-term economic interests, inadequate enforcement and corruption. Climate change impacts accelerating unpredictably. Opportunities: technological innovation, youth activism, and growing environmental awareness. Collaborative global movements for sustainability. A vision for the future. A biodiverse planet supports not only ecological health, but also human survival and prosperity. Our collective future depends on protecting what remains, restoring what's been lost, rethinking how we live with nature. By investing in biodiversity today, we secure the resilience, beauty, and abundance of life for future generations. Conclusion: the conservation of biodiversity is one of the defining challenges and responsibilities of our time. It requires cooperation across nations, sectors, and communities, the blending of tradition and technology, and the alignment of economic systems with ecological realities. With knowledge, willpower, and compassion, a better future for the planet and all its inhabitants is within reach.